Okay, it is now 7:30, so if you're ready to go, Lou, I think we'll get started.
Yep, I'm ready to go.
Excellent. Good evening, everybody. My name's Cameron Baker. I'm the Secretary of the AACE Australian section, and welcome to our webinar tonight on total cost management estimating. Our presenter tonight is Lou Vidotto, who is the President of the AACE Australia section, and also the chair of the Queensland chapter of the AAC Australian section. If you have any questions that you want to ask during the presentation, feel free to type them into the chat bubble, and we'll read them out at an appropriate juncture. So over to you, Lou.
Thanks very much, Cameron. Welcome everybody, and to this webinar. So tonight, what I'd like to cover is, if you scroll, Cameron.
Yep.
So I've got a bit of an agenda tonight. So basically, just an introduction. I would like to talk a bit about total cost management as defined by the AACE. I certainly want to talk about work breakdown structures, and they're important. I talk a little bit about the estimate process, the basis of estimate, which is where you actually document what you've gone through in the estimate process. Talk a little bit about contingency, and then open the floor to questions. I think what we'll do is maybe after the estimate process is about halfway through, we'll maybe just take a short break to go through some questions. Otherwise, we just keep going through to the end. Okay. So, good evening. So last year on one of our webinars, I talked about documenting the estimate and the importance of that document to understanding what's included in the project budget. The importance of documenting the estimate is really about documenting the assumptions you've made in the estimate, the backup, reiterating the scope of the estimate, and iterating the interface with certainly the strategy of the project, and also to what the schedule looks like. As we go through, I certainly emphasise when building an estimate, the key bits of an estimate line item are certainly the quantities, the work hours, the equipment and material, and certainly the labour costs. So we'll go through that a little bit more as we go through the webinar tonight. Sorry, Cameron, just go back.
Yep.
Sorry, a bit fast. So yeah, so tonight I'd like to share my experience about the estimating process and the critical relationship of the estimate to project success. We've just come off a project where the estimate was built. It did not reflect the current scope of the project. It did not reflect the current, the project quantities. And it was a nightmare. We had to kick off a fairly intense change management process, and it was very difficult to follow. And the other bit that made it quite difficult was also the basis of the estimate wasn't clear about how the estimate was built and what the assumptions were, and what the strategy that they incorporated was. So it made it very difficult. So tonight, the critical relationship of the estimate to project success from an estimator's point of view. Sorry, Cameron, next one. So who am I? Lou Vidotto. Thank you for the introduction, Cameron. I've had 45 years in resources and infrastructure projects around Australia and around the world. So most of my career has been in project controls. So I've done a lot of cost engineering, planning and scheduling, and a lot of estimating, and certainly headed up project controls teams. Project controls managers are a key part of the project management team, and I can't estimate, or I can't stress enough the importance of that role in the overall project. I've done a lot of project estimating. I've also developed some project controls training programs to share experience, knowledge, and basic skills to our profession. So my training is primarily about the skills you need to work on a project, including what it means to be a cost engineer, what it means to be able to forecast, what it means to be able to understand quantities, and understand what field activities are really like. Thanks, Cam. Okay, so total cost management. So total cost management is the total cost management as prescribed by the AACE. And it's defined as total cost management is the sum of the practices and processes that an enterprise uses to manage the total life cycle cost investment in its portfolio of strategic assets. So what does that mean? I put in just a simple diagram that we use to sort of describe the project life cycle. And if you start in the bottom left-hand corner, we talk about concept studies where an owner or a client says, I want to develop something. I want to build a railway line. I want to build a new mine. I want to build a new stadium. What's it look like? What's its purpose? What's it going to serve? And the owner put some criteria around that. So the team that's engaged to actually bring that to life starts to look at the team that's engaged to look at the project will look at the options that are available to achieve the business case. And at the end of the pre-feasibility study, that's what we call that phase, we select one which best fits the criteria developed by the owner or the client. In a feasibility study, one option is studied, one's recommended if it meets the criteria for cost and schedule and functionality and quality. If not, then really we recommend in a study scenario to go back and recycle, and either it was the wrong option, or it was also maybe not studied appropriately. So once you've recommended a feasibility study option, projects really go through. Okay, John. Projects really go through a financial closure period where the project has to get funded or funds appropriated from company treasury or something like that. Normally during that period, we would then look at a phase called project readiness, where implement systems and processes, do detailed planning and do project preparation, lock in your contracting and procurement plan, and get ready to deliver the project. We had a webinar last year by the IPA, who looked at stats on project successes and project failures. And what they said was that a project that has, or a company that has project controls in place during the early stage of the phase of the project life cycle is 40% more likely to be successful in the execution phase, because you've got your systems ready, you've got your detailed planning ready, you've got your project preparation ready. So I thought that was a pretty good stat. Execution phase. The approval of the project will mandate what is to be built in terms of scope, schedule, estimate, contracting strategy, quality. So one of the things that the estimate contributes to, and we'll talk a bit more about that as we go along, is it is the fundamental document that becomes the budget. And the budget has to reflect how you're going to build the project and what you're going to build, etc. And we'll talk a bit more about that. At the end of the execution phase, you hand over to operations to operate the project, whatever that project is, and it expects to have a return on investment that meets the original business criteria. So a long way of going around, and just to reinforce the AACE total cost management, as I said, which is the sum of the practices and processes to manage the total life cycle cost investment. Thank you. Go next one, Cam. So total cost management, AACE prescribes to plan, do, check, act. So what does that mean? It means plan the asset solutions or project activities, do, execute, initiate and perform the project or project activities in accordance with the plan, check, make measurements of asset, project or activity performance, and act. Act means assess the performance variances from the plan and taking action to correct or improve performance to bring it in line with the plan or to improve the plan. So what that means is that your project team, for whatever the project, needs to understand what the plan is. They need to initiate the plan in the project in accordance with that plan. They need to check, which is measure progress, measure deliverables, measure quality, measure time, if that's what's required. And then act. If a project's going off the rails, then take corrective action. And that's one of the things about project controls. Is really one of the functions as a project controls person is to recommend actions, corrective actions when something's going off the rails. So in order to recommend a corrective action, you need to know what your baseline, and excuse me, in the case of the budget, it's really what the estimate was based on to build that budget. So go on, Cameron. And so the cost estimating, total cost management talks about cost estimating, and they call it the predictive process used to quantify cost and price the resources required by the scope of an investment option. The resources required are quantities, labour, materials and equipment, and time. Budgeting, they talk about the sub-process within the estimating used for allocating the estimated cost of resources into cost accounts against which cost performance will be measured and assessed. One of the things that's important on projects in which we prescribe to, and AAC certainly, is the budget allocation process. So that when a scope comes up for award or recommendation for award or for contracting, that you allocate the budget in accordance with the scope of that work. So we always say that budget allocation is based on a scope for scope basis, not a dollar for dollar basis. And in order to do that, you need to understand what the scope is and how well it's documented in the estimate/budget. So again, the estimating process becomes a key part of the project process. And I can't reinforce that enough. Building an estimate, it's not only about what is the cost going to look like for the project. It's really being able to give it to the project team to manage the budget and help to manage the project. Next one, Cam. Okay, so recommended practices. The AACE has many recommended practices now, which have been in place for a long time, and they're also being rewritten and new ones developed. So in terms of estimating, the three parts are plan the estimate, develop an estimating plan, develop the work breakdown structure, and get ready so you understand what you're going to be doing. Do the estimate. So the recommended practices talk about the cost estimate classification system for road and rail, and also too for oil and gas type projects, mining projects. So I certainly recommend to everyone to go and look at the recommended practices, because they give you a lot of information on how to do estimates in particular, and they give you information about all sorts of things, how to manage the schedule and manage risk, etc. But tonight I certainly focused just on the estimating part of it. Document the estimate. So again, they've got recommended practices on how to review, validate, and document the estimate. And I'll talk a bit more about the importance of doing that later on. And also they talk about the basis of estimate, where you document the assumptions that you've made, the labour rates you've assumed, the contracting plan you've assumed, what the quantities look like, what the schedule looks like, your production rates for the various commodities. So again, this AACE have a fantastic library of recommended practices. So if you're not sure about something, talk to the experts, which are the AACE recommended practices. I've only listed some here. There are many, and certainly some of them are more applicable to the type of job that you're working on. So certainly go through those. Okay, thank you. Work breakdown structure. There's a lot of discussion. There's a bit of background noise. Sorry. There's a bit the work breakdown structure. There's a lot of discussion about work breakdown structure. So a work breakdown structure is really a common structure which captures the scope of work by area and facility. It captures the execution strategy in terms of allocating work packages against the scope of work. The work breakdown structure is used in the estimate to actually reflect the scope of work. So when you're reviewing an estimate, you certainly have the scope of work, scope document by WBS, hand in hand with the estimate reviews. We always, when we're reviewing estimates, the first thing we do is review the quantification, and we go through with the project engineers and just say, have we captured the scope of the study or the project? Have we reflected what the intent of the quantities that you've developed for the project? And then secondary to that is then reviewing the cost of that work. First thing is capture the scope. Make sure you've captured the scope. In an estimating package, we certainly break up the estimate by facility or area, by commodity code or discipline code, and then the third dimension is by packages. All our modern cost management tools talk about control accounts, which is really allocating the budget into a commodity, a facility, and a work package. And usually it comes directly out of the estimating process. So you can't really build your budget effectively if you haven't done the estimate effectively. Commodity code structure. Certainly it's common work activities in each WBS. And also commodity code structures are the discipline work that you need to do to build each of the facilities, and includes obviously earthworks and concrete and steel and cable and equipment and mechanical bulks, etc. The work breakdown structure also groups like items for estimating, contract pricing, progress measurement, reporting, and eventually historical data. One of the benefits of having a well-structured work breakdown structure and a reporting process is that when you come to do an historical report, you can actually match up where you started from, how you've gone through the project, and then where you've ended up at the end. So historical data then becomes extremely important to feed back into your estimating process. So you've estimated a project, whatever it is. We're about to estimate a project for a tailings raise on a mine site. And certainly at the end of the job, we would like to go back and say, how did our estimate perform compared to how it actually came out at the end? Where do we need to fine tune it? Where did we go wrong with production assumptions, et cetera, et cetera? Where do we go wrong with timing? So that feedback loop is pretty important. Next one, Can. So the common structure, as I said, the estimating process really is about capturing what the scope of the project really is going to be. I use this cartoon quite a bit. And I start off when I do training, particularly in estimating, it's really how the owner explained what he wanted built, how the project leader or project manager understood what the owner wanted, how the project leader scoped it out, so he understood something and scoped it out, how the estimators managed to estimate what they thought was the scope of the project, how the analysts captured the estimate and the data or the NPV, estimate backup. What is the data that made up the estimate assumptions, etc. And I've been on jobs before where the estimate backup is really good. So it's very clear to understand what the assumptions were in the estimate. But then same thing on other jobs, there's no estimate backup. So you start to think, where did those assumptions come from? Where did those labour rates come from? Where did those productivities come from? So again, estimate backup is important. Where's the estimate backup reflected? In the basis of estimate and the supporting files for the estimate. How the owner was billed. Owners really rely on their engineering service providers or their contractors to build the project for them. And as an engineering service provider or a project manager or a contractor, we have a responsibility to only build what the owner has mandated us to do. And then roughly, what did the owner really need? So he really wanted something fit the purpose, functional, and probably not. He may not have gotten what he originally intended. So the estimating process is really about capturing the scope and estimating the value of that scope in accordance with what the owner really intends. Again, I've built estimates that are too fat, and I've built estimates that are too skinny. So both of those are really don't fit the needs of the client. How do you get around it? Contingency analysis really picks up whether how good the base data is, and I'll talk a little bit more about that towards the end. And the estimators also need to be in tune with what the owners or the clients really want for their project. Some owners can't afford a really good standard of project, or the life of the mine or the asset might only be 5 or 10 years rather than 25 years. So it's really important to be in tune with that as an estimator, because then you actually do a fit for purpose and estimate which reflects what the owner really wanted at the start. Next one, Cameron. So the estimate process. So I've put our diagram here, which is really scope, time, cost. Important for a project, obviously, is the scope, the cost for that scope, and also the time. It's also important to know when you're getting into a project whether the project is cost sensitive or time sensitive. If a project's time sensitive, then really you need to make sure that there's enough cost in the estimate where you have to work overtime or accelerate or have extra contingency in there for things that might impact the schedule. And vice versa, if your project's cost sensitive, to make sure that you've only got enough in there to actually build the job in accordance with what the owner can afford. I worked on a project a long time ago where the project was actually cost sensitive. They were developing a new metal industry for Australia, and they had patents in place for the alloys with that metal. And they had in their patents for the metals, they had agreements about progressively building it into the manufacturing process, making sure that they could test it and make sure it was fit for purpose, etc. And they were cost restrained. They didn't have a lot of money. When the contract was awarded to the prime contractor, the conditions of contract were such that if the re-estimate of the project was outside what the budget plus 10% was, that they'd incur all sorts of penalties in terms of liquidated damages, etc. So when we ended up doing the re-estimate, we were outside the 10% because the prime contractor had really made the process foolproof, and he had redundant piping system, redundant equipment systems. So there's no way that the project could build the job for what the budget was. It failed. And the lenders walked away and said, well, we can't lend you the money. We said we'd lend you the money if you were within 10% over what the original budget was, and it wasn't to be. And that was a major blow. And it certainly taught me a bit of a lesson about being sensitive to whether a project is cost or time sensitive. So at any point in the project life cycle, an estimate is meant to reflect the cost of a scope of work based on the documented and quantified scope of the project. I can't stress enough the importance of quantities by the commodity code structure and standard units of measure, so you can estimate it. The proposed execution strategy, which depends on the project type. Some projects are owner delivered, some projects are EPCM, some projects are alliances or partnering type agreements. The important thing is what is the contracting purchasing plan that needs to be reflected in the estimate build-up. Small contracts require many more contracts on a project, which require more contractor overheads, a lot of interfaces between the contracts, etc. Large contracts have their own set of issues, where you have large contractor teams running the project, and you don't always get the transparency as the owner or the managers to what's going on. Again, the schedule for the project is important. A lot of costs are really time-based, particularly a lot of your management team. If a project schedule overruns, then that automatically overruns the time for a lot of your management team. So it's important to know what the realistic schedule is for the job. The risk profile. When we're building estimates, it's important to know what the risks are. And one of the things that we talk about a lot is what is the risk register. And that's really then comes to when you do your contingency analysis, covering for those risks, and the company or the owner will take a view on whether they can afford that risk or they need to put it into the contingency. Contractors' estimates. When contractors bid scopes of work, they look at the risk profile in the contract. They look at, for example, what's missing off the drawings or the quantity takeoffs, and they'll make their own risk profile as to what their bid needs to be and how they're actually going to make money out of it at the end. Next one, Cameron. So the AACE, again in the total cost management, have put together one of the charts they do. It's based on plan, do, check, act. So this estimating process I've just taken out of total cost management. So it's worth going into the total cost management and having a look at it. But again, they talk about plan for estimating and budgeting, quantify the scope, cost of scope content, price the cost estimate, simulate and optimize the costs if you have to, getting back to what the owner can afford, develop and maintain methods and tools. And then you get into budget cost, analyze cash flow, review and document the cost estimate. And then when you get into project execution, you start to bid the cost estimate, awarding scopes of work into procurement and contracts. And again, there's a myriad of ways of doing that, letting contractors buy all the equipment, some of the equipment, or all of the equipment, or some of the materials, or all of the materials. So again, that execution strategy for your project determines how that's actually built into the estimate. For example, if a contractor buys materials or equipment on a project, then in the estimating process, you would allow a margin for the contractor to go through that process. If the owner's going to buy it, or the EPCM, then that's reflected in the size of the procurement organisation to do that. So each of the projects is sort of fit for purpose on how they want to be built. But as the estimators, you need to make sure you understand how it's going to be built, and make sure you've got estimated costs in there to manage that execution strategy. And again, I just recommend you just go back. Sorry, I just recommend going to the AACE recommended practices and have a look. It's got a whole bunch of references and interfaces, so it's pretty valuable stuff. Sorry, Cameron. So again, the estimating process is really about classes of estimate in accordance with AACE. So they talk about class 5 estimates, class 4, class 3, class 2, class 1, and they talk about the maturity levels of project definition deliverables, where a class 5 is concept or screening. So a lot of the estimate methodology is based on historical data, parametric estimating, maybe some equipment that sort of fits within what the project's going to look like. We've done a fair bit of analysis now on different types and sizes of projects, and we think that if you know what the equipment estimate looks like, what sort of value, then there's enough data from history and projects to be able to determine what the capital cost for the directs looks like, and also what the capital cost for the indirects looks like. And obviously based on where the project is and what region and what type of project. But certainly for that sort of level, understanding what the equipment looks like, it might be a primary crushing system for a mine, which might cost you $2 million. So then you might think that the capital costs are going to be something like $20 million or something like that. Class 4, there's some maturity done in project definition. It's usually for study or feasibility. So you talk about costs per length, and some of the items will be factored, for example, electrical or even piping. The expected accuracy ranges vary depending on the definition. Sorry, I'm starting to get some questions, which is good. So class 3 is really about a budget authorization or control, semi-detailed unit cost with assembly level line items. Again, the range is -10 to -20 up to +10 to +30. Class 2. Class 2 is really a lot of definition. It's either a control or a bid tender. We would call a class 2 when you start to get up to about 60 or 70% engineering definition. We talk about a definitive estimate, where you've probably got a fair amount of definition on the quantities. You've probably bought a lot of the equipment already, or at least contracted it, and you've got some experience in the field. And then that's reflected in the range, the expected accuracy range. So your contingency starts to get less, but with more confidence that you're going to meet whatever the estimate comes up with. Class 1 is really a check estimate or a bid or a tender. Contractors will tend to do a bid or tender estimate based on a bunch of quantities that have been taken off, which are probably getting towards IFC. And the detailed takeoff. If quantities aren't sort of designed yet, then it's going to impact the accuracy range of that estimate. And also too, contractors will then take a view on what margin they need to allow, or where they can actually where they have to boost up the estimate or take a bit of a risk on what the quantities are like. This diagram here, the influence curve, really when you start off in a class 5, you've got a high range of accuracy, and as you progress through the classes, you start to narrow down on the contingency that you need, and certainly the accuracy range for estimates. There's been a lot of studies done about what those numbers look like in reality, and it's probably a lot of it's reflected in the estimating process. This estimate class table is a number of versions of that by AACE. So again, depending on whether it's an oil and gas project or an infrastructure project or a mining project, it's slightly different, but the function is still all the same. As you get more definition, you get better accuracy and a better value of the estimate that you're working on. Okay, just next slide, please, Cameron. Yeah, so we did a bit of a diagram that we use on when we talk about the estimate life cycle, and we just say, look, during a concept phase, you've got a fair amount of contingency, and your estimate is whatever it's going to be. So high-level description only. Pre-feasibility studies, your estimate gets a bit better, and accordingly, your contingency gets a bit less. During feasibility study, your cost estimate, again, better accuracy. So you're able to quantify more of the scope. Again, your contingency is a bit less, theoretically, provided you've captured all the scope and it doesn't change as you go along. In execution phase, you're really talking about having a budget, and you've got contracts and purchase orders for all sorts of equipment and material, and the contingency is less, and you start to use that as you start to get overs and unders on your contracts and purchase orders. And then the key thing, a key thing is at the end of the job, you've got actual costs. So as you start to go through closeout, what did your job actually cost? And certainly if a schedule is set, and how long did it actually take? So during execution, your engineering progressively gets up to sort of 100%. And then in closeout, you're able then to determine what the actual costs are. And again, one of the things to remember, depending on where you work and who you work for, try and as an estimator, try and get those actual costs to start to feed back into the cost estimate database to see, okay, our assumptions were right or were wrong with production rates. How many cubic meters of dirt can a scraper crew move per shift? Okay, our assumption was 5,000 cubic meters. What did they actually get on that job, more or less? Why? So that analysis of historical report then becomes pretty powerful to make your estimating better. I know that many companies now are starting to realise the value of that. As a project controls professional, it's important to try and get involved in that contract and purchase order formation stage to set up the pay items so that you can actually align actual costs back to your budget items, and start to get that correct real correlation back to how your estimate was built. That's a bit that I find as a project controls person that's probably weak in a lot of companies, that the contracts and purchase order line items in a contract are done by the procurement folk, with sometimes little or no input from the cost engineers. So that's something that I certainly try and promote. Get involved in the build up of the bids for contracts and procurements to align one with your cost code, with your work breakdown structure, your commodity codes, and back to your budget items. So that's a bit of a giveaway for tonight. Okay, so next one. So the estimating process, so different participants in a project have different requirements. Certainly in the estimating process for an owner, it's really things like securing sufficient funding to deliver the project. Uh, Make sure that you've analysed your options to support or prove the business case. Do your financial modelling and profitability calculations. Operations readiness. Get your operations team ready to operate once that you hand the project over. And that's certainly something that sometimes a bit cloudy. When do you actually hand a project over to operations? And then when you convert from spending capital costs to operating costs. So people say you hand the project over once it's at nameplate, or some companies say once commissioning is complete, you hand it over, which is fine as long as that's defined as part of your estimating process. When do you actually hand over? And then when do you flick from capital cost to operating cost? Funding reserve is really your contingency analysis, based on your contingency analysis. So we would normally quote an estimate for a project based on a P50 accuracy, with then some contingency, some management reserve, which the owner really needs to understand whether it's a P80 or P90 or a P20 or a P10. And I will talk about that towards the end of this webinar. For an EPCM, really it's about developing technical solutions for the project options and delivery solutions for the project options. So an EPCM is focused on how do I solve the project, how do I implement or design the project scope to deliver an outcome for the project that's acceptable to the client. A lot of times EPCMs are focused on their portion of the budget, and then the owner certainly will consolidate that into the overall budget for the project and schedule, obviously. Contractors and vendors estimate or provide bids for specific scopes of work. And certainly they take a view on what's missing out of the drawings, or what's missing out of the pricing schedule, and they'll take a view as to how they go about allowing for that, and how they pitch the initial tender or bid to the owner. So the estimating process is really a bit different for the different entities on a project, but the processes are the same. I've done prepared bids for contractors. And again, building the estimate plan and doing the basis of estimate is something that we've done. And it's always helpful because sometimes you find in a lot of companies that the estimators work almost a little bit independent to the project managers and construction managers. So you get that misalignment between the estimate and the scope and the strategy. So again, going back to what the AACE and we promote is do your planning, do the estimate, then do the analysis of it. Next one, please, Cam. So what does your estimate structure look like? It really has to be based on quantities by a code of accounts, which is your facilities and commodities. It has to identify labour and equipment resources, labour cost and labour hours, direct labour hours, equipment and material costs, and all allocated to work packages. And the reason for that is that different parts of the organisation or the team need that information. So the schedulers need to know how many man hours are going to be on the job so they can actually do the resource curves. The schedulers also need to know what the quantities are so they can do their commodity curves and know that they have to install X number of meters of pipe per month in order to meet the milestones. The materials cost, where does the project need to buy, what materials do they need to buy, where are they going to buy them from, and how's it going to get to site? Is there materials available on site that they can use? Yes, no. If it's not, where does it come from? How much do they need, and how much is it going to cost? And then always allocated to work packages. And again, that comes back to our modern cost management system that talk about control accounts, so which is really a facility or an area, a commodity code, and a work package. Next one, please, Cam. So, sorry, this one's a bit hard to read, but it's just meant to illustrate that on the left-hand side, you've got your areas or your facilities. This comes off a mining project that we worked on quite a while ago. And across the top, it's really what the quantities are. On a facility summary, you wouldn't have your quantity summary because an area is made up of different numbers and types of quantities. But if you were doing this by commodity summary, then you would have the quantities. It's really what sort of freight tons, depending on where your project is. Freight could be a significant issue if it's a remote site and you have to get stuff from overseas. What your labour hours are for each of the facilities, which then gets reflected in the schedule, what your plant equipment costs are, your vendors' reps. Another significant issue is really how much do you need to allow in your estimate for vendors to come during installation and then also during commissioning. So that's something that could be significant depending on your project. The bulk material costs. Now, bulk materials are things like concrete and steel and cable and pipe, etc. The freight cost, which is really the cost to bring the freight tons to site. Your labour cost is really how much of those hours going to cost for each of the facilities on the project. We talk about subcontractor distribs. If I'm a contractor and I'm going to build that project, I'm going to have a number of men working on site for an amount of time, but my overheads are going to be things like my site huts, my site vehicles, my head office expenses, my camp costs, my travel costs, my consumable costs, my supply of PPE. And there's a whole raft of things that a contractor, my management cost, my project management cost, a whole raft of things that a contractor has to supply to support the labour to build the job. So we do separate calculations of those on a project, and we tend to do it by work package. And that's why it's important when you're building an estimate to know what your execution strategy is. Certainly an earthworks contractor is going to have bigger overheads than an electrical contractor. So in terms of equipment used and things like that, labour rates will be different because an electrical contractor will have probably higher labour rates because he's using specialty electricians, etc. Whereas an earthworks contractor will have more labour, although equipment operators cost a fair bit as well. Construction equipment. On some projects, it's really the construction equipment, particularly for the earthworks, what's it going to cost in order to deliver those facilities. And then obviously the total. And then also going down the left-hand side, you've really got some areas of direct facilities, which is really what's going to end up on site when you walk away. Temporary facilities to support the construction. Things like site offices, temporary fencing, temporary roads, etc. Construction support is really things like concrete testing, surveying, and things like that. Pre-commissioning is really coming in and making sure that all the equipment works under water load usually. And then you've got engineering and project management, owners management team. Now, those will vary depending on how the project's being delivered. And certainly that's in your execution strategy. So that needs to be taken into account of as an estimator. Owners management team, operations readiness was the first one, and then owners management team. Then legal costs, it might be significant, insurance, pre-production costs. What's not on this item here, I probably cut it off a little bit too early, is contingency and escalation. Escalation is a significant cost to projects that we often don't take into account depending on the duration of the job. Again, it might be in your estimate planning, you nominate a base date for the estimate, and then you've got to say, okay, all the costs in the estimate are as of the date, but in order to finish the job, which is 2 years or 1 year or whatever, we think the escalation is going to be XYZ. And you often get that from your owners or use CPI or different indices. Okay, so this is pretty much on the estimate structure. Do you want to do some questions now, or do you want to keep going and do them at the end? Cameron?
Sorry, I had an intruder. No, we can do some questions now. We've got one from John Boyle. Does the AACE give recommendations for P50s?
It gives recommendations on the range of accuracy that you should allow in your estimating. Certainly, a P50 is the accepted norm for a project budget. And then companies will either do an upper and lower limit of P80 and 20 or P90 and 10.
We've got a couple from Frank. Can you please provide recommendations regarding estimating escalation?
Okay, so when we calculate escalation, we look at and there's complex ways of doing it and simple ways of doing it. So really, for example, on the estimate structure I've got on the screen, you might look at when, for example, area 27,000, which is product handling, when it starts and when it finishes. And then you might look at, okay, you've got about a 12-month period. What sort of escalation rate could you have in that area? Probably a lot of mechanical equipment and stuff. So you might look at CPI, and there's also things like steel price index and things like that you might use, and then calculate it out that way. The way that I've done it at a high level is really to look at the overall schedule from the base date to the end of construction and do a centroid of expenditure. So 2/3 along the way of a project, very simplistically, you've probably spent half your money, and then how far is that along your schedule, and then use things like a CPI or a published escalation rate that thinks they think it's going to happen. So depending on what your requirements are from your owner, you can either do it very, very detailed, or when you're an estimator, particularly during feasibility studies, etc., you might look at just doing a centroid of expenditure. And I'm happy at some stage to go through and show you what that looks like.
We've got another question from Frank. What percentage of project definition is recommended before requesting approval for funding from the client?
Probably requesting funding from a client is really towards the end of a feasibility study. Now that varies from company to company. Normally, in my experience, it's usually about when basic engineering's done, which is about 30 to 35%, maybe 40% engineered. Some companies, like some of the big mining companies, will want engineering to be at sort of 50 or 60% before you finish the feasibility study. So what that does is gives you a bit more certainty in the estimating process, but it takes longer. So depending on what the strategy needs to be, you might want to go on your 30% engineered, or 35% engineered, or go up to 50 or 60%. Now, during execution phase, when your engineering's at about 60 to 70% complete, in my experience, it's time to sit back and get a quantity dump on the project and re-estimate the job. From that point in time, you should be fairly sure that you know what the costs are going to be for the project, unless there's stuff that's still in the woodwork for claims and things like that. Maybe some things that haven't reared their ugly head on the site yet. But generally, you've done enough work at that stage to say, okay, we think the quantities really reflect what the job is going to be, and at 6-7% is almost getting towards IFC anyway. It might certainly be better in some of the commodity disciplines and a bit less in the latter ones, like electrical and stuff, but generally around that. So for a DE, a definitive estimate, the criteria was always engineering to 60, 70% complete, all the major equipment at least committed, and some experience in the field on construction contracts. So you know what the labour rates are and you've got an idea of what production rates are and you can adjust your assumptions accordingly.
Yeah, on our Victorian government contracts at the moment, there you need to be about 80% confident on the costs before you go cap in hand and start the discussions.
Okay,
So,
fair enough. Yeah.
yeah.
Wow.
which is fun. Sergey, I think you had.
So just to on that one too, I remember sitting in a presentation with the Australian Cost Engineering Society a number of years ago, and Department of Main Roads were always getting hammered because their estimates were going over. So what they did, they decided to actually not go back for funding until they were until they'd estimated the P90 accuracy level. So they were pretty sure the job wouldn't overrun. But then the other side of the coin, they ended up with a lot of money left over, and so it put pressure on the Treasury because they were talking about some big projects at that time, big road projects. So yeah, so 80%, it's a fair bit.
Yeah.
Yeah.
Sergey, I believe you had your hand up earlier. Did you want to ask a question? You can unmute your microphone if you do. Either that or you can type it in the chat and we'll answer it at the end.
Okay.
I think we'll go on to the next slide.
Yeah, please. So why document the estimate? Because you've got to create a budget for cost management. So you need to know what the assumptions are for the budget. You need quantity and labour resources for the schedule and execution progress measurement. You need to know what your quantity curves, your commodity curves are, and what your labour resources are to install those quantities, and that needs to be actually needs to be quantified. You need to know what your risk register looks like, what risk have you included in your contingency analysis, which ones are you at risk. You need to do your contingency analysis and look at how good your estimate is, and then you also, and it's all captured in the basis of estimate. Okay. So the AAC defines the basis of estimate as a required document. The one deliverable that defines the scope of the project can become the basis for change management. Not can, does. And it certainly depends on the transparency of information. If you have a baseline, which is your budget, which comes from your estimate, which is defined from the basis of estimate, you can do change management. I remember on a project where schedule wasn't finished by the time they got to execution stage, and the planner on that job kept changing the schedule because things kept changing. And at the end of the day, I had to say, look, just baseline it. Just say that's it, and then start your change management. And it's the same with your budget. And you've also got to build the base of estimate with the stakeholder in mind. Your owner, your project team, you might be negotiating a contract, and certainly the planning team to match the estimate with the plan. So it's really about understanding what is in the estimate, how you built it, and what the outcomes of that are. Do the quantities reflect what's in the scope? Does the split of the estimate reflect what the contracting strategy is? And that's another thing too that in my view and experience, if you change the contracting strategy on a project for whatever reason, that constitutes a scope change because suddenly you're changing the way you're delivering the project and changing one of the base pillars of the project. Okay, build base of estimate with the stakeholder in mind. So yeah, just next one, Cameron. So what do you include in the basis of estimate? Again, the work breakdown structure and commodity code structure, the project scope, reiterate the project scope. Generally on bigger projects, you'll have a scope document. On smaller projects, you have a scope statement, which you then put in the base of estimate just to reiterate what the scope is, and it's all in one place. The estimate methodology, the execution basis, things like the planning basis, the labour rates and unit construction build-ups. Unit construction in estimate is often done from ground up. Say, okay, I've got to install this structural steel. What sort of crew do I need? How long is that going to take? Where's the laydown area? A lot of times when you're building major estimate, you don't have the luxury of being able to do that. So you use norms. So to install light structural steel, for example, you use somewhere 25 to 30 man hours per tonne. But certainly that needs to be based on some benchmarking data, if nothing else. And again, I haven't talked about benchmarking, but that's a key part of the estimate review process. I'll probably talk about benchmarking another time. Productivity, what labour productivity are you going to get and why? Where's the job? How far is the job site from the laydown area, from the gate, the project gate, and again the basis for materials and equipment pricing. Okay, so next, qualifications, opportunities and exclusions tells you all about the estimate. It tells you what's included and what's excluded. It tells you what the risks are on the project, the risk register. As an owner, it's important to make sure that if you have had an EPCM or a contractor give you an estimate with qualifications, that you know what those qualifications and exclusions mean. And if they're part of the overall project scope, you've got to make sure that you've allowed for it. And that's where an owner's project controls team starts to add its value, where they start to analyse what the gaps are and say, look, holy hell, the contractors or the engineer, etc., hasn't put this in, or they got no growth on the quantities, for example. So, okay, we need to make sure that we add it in. So it's that understanding what in an estimate, what's not in there, as well as what is in there, that's important. And usually it's documented in the basis of estimate. Sorry, Cameron, next page. So in my experience, a good basis of estimate enables constructive review of the estimate by an IPA, independent peer review, or an owner or investors, etc. It prevents inference and suspicion by the reviewer. If a reviewer is reviewing an estimate and they don't know what's in it, and of course with the base of estimate, it's likely they'll question it and say and make their own assumptions about what it should or shouldn't be. So hence it's important to document it. Again, document assumptions and qualifications, and it provides the basis for change management. Next one. So I put a couple of slides in just for contingency ranging. Again, this was a table that came out of a review where the base for the project was 3.5 billion. And once we looked at all of the estimate characteristics and the schedule characteristics, how the quality of the estimate data, and also some of the risk that were inherent in the job, we came up with a P50 estimate value of 4.6 billion. And then based on the spread of the Monte Carlo curving, it came up with a P10 of 4.075 and a P90 of 5.153. Again, we would normally state a project estimate at a P50, but we talked about a management reserves. Again, AACE states about a P80, which means you'd quote the estimate at a P50 plus the management reserve of another up to 4.4952. But so again, some companies go to the P90 in order to be secure, and they don't want to overrun or underrun. So that's all I've got for tonight on the estimating process. Certainly, some of my experience I've talked about, and I've certainly reinforced what the AACE recommend. So we probably understand what's in there and work to it, or sometimes by default, but where we're not sure, we'll defer back to their recommended practices. So what I'd like to do now is open the floor to questions. So
Yep.
I think Cameron will sort of.
Yep, John's got his hand up. You unmute yourself and ask a question, John.
Can you just go back a slide, Louis? Just go back one slide. Yeah, just interesting here that, and I asked the question about the P50 before, and I knew the answer, but if you look at this P50 here, and then you ask yourself the question, because a lot of people don't get this, that the P80 accuracy range is around the P50. So if you look at that estimate there, it's plus 16 minus 14. That's quite a tight class system.
Yeah. Yeah.
So a lot of people miss that though. They just quote that number and they think it's around the base, and it's not.
Yeah.
It's around the P50. So I look at that and I go, well, that was a pretty tight range.
Yeah.
For I don't know whether that is a class 3 or a class wherever it is, but it's a tight range.
It was a class 3 estimate.
Yeah, so that if you look at if you go back to the other one, a class 3, you should be plus 50 minus 30. So
I can't tell you what job it was, but it had knobs on it.
Yeah. But what I'm saying is that's tight. That's very tight.
Yeah.
So and the only other point I wanted to make is I do like the AACE classification system, and I do use John Holman's model quite a lot.
Okay.
I think where that class system needs to go with the AACE is people quote, percentages, but really what John's done is he's really raised a good point around what those definitions are for maturity in certain aspects of a job. Like, let's talk about geotechnical data and what really should be done at various class levels. And I think the whys I'm trying to educate my clients to try and say, well, okay, your gate systems really should align, and you should start to think what those various aspects of a job, how mature they should be at various gates when you're going through a class system. And a lot of people don't realize that, because I'm a risk manager, but really, you're right, it is about scope. And I think if clients can start to think about that class system and break down the classification system to another level, you can really start to drive your deliverables of what needs to get done from maturing the scope by understanding what you need to get done for each class system. That's the biggest lesson I'm trying to push. So I think John's on the mark,
Yeah, there's another table that I haven't put in here, and it looks at what level of deliverables you need for each stage of an estimate, or each stage of a project. And geotech's certainly one where it says at a pre-feas, it's really historical data. Maybe for a feasibility studies, you've done a bunch of drilling, but they talk about preliminary, they talk about conceptual, and they talk about final. But then it's really
it's too high,
the definition of those, what the definition of the definitions are.
Yeah, if you can get it right, and that's what John does in his model, which is a great definition. And what it helps people do and estimators do is saying, well, hey, we're at this class, where's the engineering deliverable that I need to make sure that I can assure that I'm at this class. So that's the one takeaway for me from that is, if understand the class system, it's about scope, and you're spot on. And if you understand what you're going to deliver at a certain point, you will deliver your project. So anyway, I'll shut up there.
Yeah, thanks, John.
We've had a couple of queries. Can we have a copy of the slides?
Yeah, look, I think you're going to actually put the slides up.
I can save the presentation to the AAC Australian section website, and I'll send out a link to all the people who registered to attend this evening, so that they can get access to it. And just so everybody knows, the video of this, or the recording of this, will be on the AAC Australian section YouTube channel. Usually takes about a week to clean up the recording. and post it. So that will be there, and you'll get a link to that as well. Sergey's gone and posted the question: how cost contingency link to schedule contingency? I'm struggling with my management to explain schedule contingency is needed to include into project master baseline.
Okay, so there's two things. One is the cost estimate, the budget really reflects the cost of the scope, and the schedule reflects the time taken to build that scope. In this analysis we tried to link cost with schedule. So a schedule delay would cause a cost increase.
Yeah, and all your better projects do have the cost and schedule linked, because if you don't have them linked, then there's a disconnect and people get more confused. And it's a lot harder to manage the project if your schedule and your cost basis aren't referring to the same thing. So yes, your cost contingency and your schedule contingency should be representative against each other.
Yeah.
But it all comes back to documenting everything. So you need to have both your basis of schedule and your basis of estimating documents up to date and cross-referenced, so that people can actually understand what each of them mean and how they work together.
Yeah, look, you're absolutely right, Cameron. So tonight I've sort of focused just on the estimate and basis of estimate, but certainly the parallel activities, the schedule plan, the schedule and the schedule basis. Some companies are also now going to a combined. For example, BHP, when we do a fair bit of estimating with them, and they talk about an estimate and schedule development plan as one document, and also they're starting to go towards an estimate and schedule basis. So because they are linked, and a lot of the stuff in those bases are common.
Okay, I think that's it for the questions. If anybody else has any questions? I think that's it. Unless
yes, look, thank you. Thank you, everyone.
Can I just make one last point? I think Lou touched on it. I really do think the whole issue of around sort of benchmarking and P50 guidance is an issue. And on the one hand, you've obviously got the likes of Flyberg sharing in his latest book, how to build big things about guidance on around the mean for various types of projects. So I do think it's something the AAC should think about a little bit. And then obviously from a benchmarking point of view, he's on that that reference class forecasting side, which obviously is seen. John looks at that with funny eyes when he looks at that sort of stuff, but I still think it's a good idea to sort of have that version that he's got, and especially from the Green Book out the UK, where there's a lot of great benchmarking data against rail and road projects for P50s and P90s, which is an excellent reference information, So I really do think, there's some good stuff out there that's been done elsewhere. That, parametric is great. Parametric, contingency forecasting. And I think there's that systemic bit gets missed by Monte Carlo. So I think that whole version of, I call it the Cyclops eye, where I look at the Monte, I look at the parametric, and I look at the reference class forecasting to give me an idea what the contingency should be. Don't be a one-eyed monster with Monte Carlo. That's my sort of
Look, for me, John, the benchmarking is a whole different subject. I've reviewed estimates where there's been benchmarking put in by an engineering service provider, and they quote the projects that I have experience with, and the benchmark rates are nothing like what I know them to be. So the key thing for benchmarking is to get your actual data on your projects, and feed them back into your estimating process, so that the different commodities on different projects in different regions took so long to build and cost so much to do.
Yeah.
Cost is certainly different, and I tend not to benchmark costs, but certainly effort is what I think is important.
Yeah, well, the unit costs keep changing quite rapidly these days.
Yeah, that's right. And it's only really
which is
reflective of,
part of the problem. The quantities don't, but
Yeah.
but the cost per unit quantity changes
Yeah.
a huge amount. I was just going to say, if people are interested in the cost estimate accuracy range and contingency determination, they should have a look at the recommended practice 119R-21. It has links to a lot of the other recommended practices as well. So if you start from that point and branch out, it's a pretty dry read, but it will give you an idea of where to head.
Yeah. So just to wrap up, I think the most important thing is to get your scope documented and the quantities for that scope documented. Then everything else should flow. An old boss of mine used to hammer me and used to say, "Quantities build projects, Vidotto." So you got to know what your quantities are.
Okay, I think that's it for tonight. Thank you, Lou, for giving us that presentation, and thank you to everybody who asked questions. It's always good when people ask questions, especially John. Thank you for your input. This presentation will be on our YouTube channel within about a week. I'll send a link out to everybody who attended tonight. Also a link to the presentation slides itself. We'll put that on our website so that you can access them. So otherwise, thank you and enjoy the rest of your evening. Or for those of you who are overseas, it's probably morning, so enjoy the rest of your day.
Yeah, thanks very much, everyone. Thank you for attending. Good night.